Hi, my name is Stuart, and today we're going to talk about an overview of Git from the practitioner's point of view. So I'm not going to try to do a Git tutorial in this video. There are plenty of really great ones here on YouTube and other places. What I am going to do is highlight some best practices and useful things to know for people who use Git every day. So just to be clear, what Git is it's a source control system invented by Linus Torvalds. And its virtues are that it's small, it's fast, it's open source. It's designed to ensure the integrity of the files that are committed into source control. It supports branching and merging in all kinds of different ways. And we're going to talk about some of those ways in a little while. And it's a very robust source control system, and I guarantee you that every single large dev organization you have any respect for, including Microsoft, has adopted Git. As we said, Git was invented by Linus Torvalds, and functionally the way Git works is that it's designed not to have any funny stuff. It's designed to use the file system and only the file system, at least from the point of view of the developer, by stashing all its mechanics in a .git subfolder. And if you're really interested in how it works, there's some amazing videos on YouTube, including one that drills into the innards of Git in a truly profound way and shows you a bunch of stuff. And the other thing is about Git topology. So if you're doing an open source project or you're doing a little project for yourself, and, you're going to be, the usual developer person where you're going to have a lot of back and forth and, you're going to do some what if things and some refactoring things and just some experiments and stuff. All you need to do to have source control locally is to go into the root folder of wherever your project is and say git init. And then at that point, you have all of the available features of source control, but in a really contained way, all within that folder tree. Now, most corporate enterprise developers don't do that. We work in a hub and spoke model. In other words, we rely on Visual Studio Teams services or an Azure DevOps or a Bitbucket or a GitLab or a GitHub as a central repository. And when we do that, what we're doing is we're making the care and feeding of that repository somebody else's problem, right? It's somebody else's problem to make that high availability. It's somebody else's problem to ensure there's DR. It's somebody else's problem to make sure that there's backup for business continuation. So in order to understand a way that a lot of Git features work, and I'll be the first to admit that when I first started using Git, I found it really not intuitive. But then I went and I found this handy diagram that I've annotated, and it really explained to me, as someone who went through a computer science curriculum, how it actually works and kind of what its virtues are. And so essentially, Git is this enormous set of links, and the links are held together by unique hexadecimal hashes. Uniqueness of those hashes in the context that they're being used, tree, blob, commit, tag, is what allows you to traverse the files in the Git file system and glue the bits together. So the root of important things in Git is a commit. A commit is essentially a bookmark that says, at this moment in time, if we were to start at the commit, walk down the chain of all the commits, and for each walk down all their trees and blobs, we could recreate at a moment in time what the source code looked like. And there's a bunch of pointers that point to the commit. One is the name of the branch. So when Git's created, there's a master branch, and there's a pointer that points to a commit that represents the head or the last entry of the master branch. When you create additional branches, each one of those gets a head too, and they simply are a pointer that points to a specific commit. And what this allows Git to do is that if you're trying to merge two branches, it figures out where the branches diverged from each other, and then attempts to stack the commits one on the other, pulling their trees, blobs, and tags behind them in order to make the contents of the to branch of the merge the same as the from branch of the merge with whatever additions were in the other branch. So in other words, it tries to reconcile in a unidirectional direction the commits, their trees, blobs, and tags. Tags are super important. We'll get to those in a minute. But understand that the mechanism where a commit is the root of a tree at a moment in time is the central mechanism behind Git, because it means that by a variety of different mechanisms, we can always get our source code back at the exact instant of time we want. Assuming, of course, that we were good developers and we made lots of commit. The finer your commit granularity is, the more control you have. And we'll talk about some good patterns for that in a bit. But the other thing is that then everything else, tags, branches, are just pointers to a specific commit. And that mechanism is both elegant and allows for a lot of power. So let's talk about branching for a second. There are lots of different weighty articles on different branching strategy. But really, there are two that are kind of the 80% use. One is the sort of small project branch structure, which is master and feature branches, right? And we only have one main line. It's called master. It's the one that's created when you create Git repo, and you take feature branches off that and you merge into that. And a lot of open source or sort of DIY projects, a lot of the repos that are local only on my machine follow that pattern. For team development, though, it's useful to have one more level of indirection, the develop branch. And so we create the develop branch off of master, and we develop stories by creating feature branches off of that and merging them back to develop. And then as we push code into production, we merge develop at the exact same commit as we sent to production, right? We merge that back into master, and then if we have to hotfix that running code that's in production, master represents the current production code. So this is a nice simple pattern that works kind of 80% of the time. And although you can do things that are a lot more complicated, one of the questions that you have to ask yourself is, if I really understand commits and tags and branches, can I get to what I want to do procedurally by simply using something like tags? And the answer 90% of the time is yes. So the next question I hear all the time is, should it be in source control, right? So the bottom line is, if you can put it in a file and it's not a secret and it's not binary, it should go into Git. And if it's not possible to put it in a file, then it shouldn't go into Git. And if it's a secret, it should go into your secrets management system. And I've done a couple of videos on these, but I like HashiCorp Vault, although there are lots of other good ones. The last thing is binaries, and where should they go? And they should not go in Git. It's not that you couldn't enable binary support in Git, and in fact, in recent versions, it's enabled by default. You have to actually turn it off. But it's that Git just doesn't deal well with files that are essentially opaque. When you tell Git that something's a binary, it's going to treat it as a big old atomic blob of bytes, and you're not going to be able to, for example, use the built-in ability for Git to do diffing based on the file extension. And Git's not a very optimal place for binaries. Now, some binary things, it's natural to go ahead and check into Git. And that is, for example, if you have a website, fave icon, or some of the standard images, or some of the font files that you like, glyphons and so on, that you might get, you might consider checking into Git. Although I'll point out that if they're assets that are owned by other people, in other words, glyphons or style sheets or style fonts that are developed by someone like Bootstrap or whatever, that you're probably actually better off pulling those into your page from the authoritative source. But if you do have other kinds of binaries, especially libraries, then you should use a package manager like NuGet, NPM, Composer. There's no package manager in Java really, although functionally Maven and Gradle will act as package manager. I'll point out that there are plenty of good binary managers out there, right? GitHub repos is currently in beta. By the time you see this video, it'll probably be in production. JFrog, Artifactory, and Nexus are both excellent repos. And there are available software as a service from a lot of different folks. Or if your programming language just doesn't have anything that looks or smells like a package manager, you have to ask yourself if you're using the right stack or not. The bottom line, though, is that if those binaries are essential for your code to work, you need to be able to version them and you need to be able to keep them safe. And why do we want to version them? Because we may want to go back to a commit whose tree of files refers to a version of the binary that's not the one at the head node, effectively, right? So everything that is in the scope of development needs to be versionable. And this is also why adopting a secrets manager with versioning turned on is really important, because one of the things that you can do is if you're storing your configuration, your secrets management, and you have to roll back, you can also roll back to what the configuration was back then, because the underlying storage entity implements versioning, and you need to and should leverage versioning in all of your development. So there shouldn't be anything that isn't versioned. The 4 big files of Git fall into 2 buckets: stuff you absolutely should have at the root of every repo, and 2 that are nice to have for open source projects. So gitignore and gitattributes, we'll talk about in a minute. And whether or not you add a README and a license file to the root of your project or not is entirely up to you. But if it's an open source project, or it's a project that is shared between you and other team members, at the very least you should have a README. And if it is a commercial piece of software, or it's a piece of open source, or something where other people can, especially third parties, can get to your code, you should really explicitly have a license file in the root of your project that explains what the terms of use are for your software. Okay, gitignore. Every programming language, when the compiler runs or when your editor interoperates with your code or other tools interoperate your code, are going to generate a lot of dross files that are not necessary to be in source control for someone else to take that source control hive, clone it to their machine, compile your stuff, and run it. And so gitignore is generally placed at the root of your project folder, and you can, in it, specify using simple regular expressions the things you do not want Git to add to your repository by default. So when you do a git add dot, for example, from the root of your project, and it recursively goes through your folder tree looking for files that have been modified in order to add them to repository, it will simply ignore files and folders that fall into these regular expression patterns. And on the right, we have the one for Visual Studio. And I don't normally make these myself. I'm a big GitHub user, and when I make a new project in GitHub, it offers to make me one of these based on my programming language stack. And it has dozens and dozens. And you can find samples for pretty much every single combination of tooling and programming language stacks on the interweb, and you can go copy and paste those, assuming that you're not using GitHub or Bitbucket or whatever, and you can seed your gitignore so that you don't end up getting a lot of dross into your source control. Git attributes is all about telling Git how to deal with, among other things, file extensions. And probably the single most important thing is, if these days when we are doing our development on Macs and Windows machines and Linux machines, that all these operating systems have very different ideas about what a proper file extension is, right? Linux tends to use a simple line feed, Windows likes carriage return line feed, et cetera, et cetera. And so what Git attributes does is that it forces Git to assume certain behavior for line endings so that as we pull and then try to compile code on different operating systems, we're going to get consistently the same behavior. And like gitignore, you should always specify a Git attributes. You know, the life cycle of working in a hub and spoke model, which is what most commercial developers are going to do, is so we're assuming that the remote is Bitbucket or GitHub or GitLab or something like that, where we've got the working directory tree that we're working in. And if we want Git to start paying attention to the change state of a particular set of files, we're going to git add them. Now, I'll point out that the git add step, if you're doing everything using your favorite text editor, say VI, and you're just working from the command line, you're going to have to git add yourself. But if you're using Visual Studio or Code or one of the other really great platforms like Eclipse or whatever, what you're going to discover is if you enable those IDEs to do it and you've put a gitignore in your root, that based on the project code that it's looking at, as you create new files or modify files, it very well may offer to git add them for you. And personally, I let it do it in the background for me without getting in my way and asking me every time I create a new file. But the committing, which is saying that the files in the current state that have been added, and by the way, add doesn't necessarily imply a new file. It just implies that the file that we have changed, we want to propagate that change into the repository. So, normally you manage Git commits yourself. And again, if you're using a good IDE, they'll have a little interface that lets you put in a comment or a note and go ahead and create a commit, which updates the tree that we showed you before. And if you're working in a hub and spoke model, and let's say you're working in a feature branch, right? We're going to want to safeguard that code to the hub, right? And so we're going to do a git push. And we want to do that adding, committing, and pushing with some frequency because in case you have an NBI, a negative bus interaction, that is you got run over by the number 10, we want to make sure that the value that you deliver during the day is somewhere safe, like your feature branch on the remote machine, where it will get love, it'll get backed up and so on. But the other thing is that every developer has lived through my operating system has turned my bits into a blended bits and I hate my life. And so if you get into the habit of adding, committing, and pushing to your feature branch, it doesn't mean that that code is going to go in and be deployed and stuff, right? It's just safely sitting in a feature branch over there. Then if you were to lose something, you won't lose very much at a time. Another way to look at this is the Git work cycle. So the Git work cycle, as in blue horizontally, your branch. And again, I'm assuming we're working on a team project, so we're going to have a develop branch. And so the first thing we're going to want to do is make sure our develop branch is up to date. That's step A, where we pull the code from the origin, the remote repository, and we pull it down locally. And then in step B, we're going to make a topic branch, right? And what is a topic branch? It's just a pointer to a commit. And as we add commits to our topic branch, right, the head pointer in the topic branch is going to move and we'll have a series of commits. And so we're going to work along adding, committing, pushing to our remote over and over and over again. And we're going to do that until our code is worthy, or at least we think it's worthy. And then in step D, we're going to do a pull request. And a pull request says, I would like the code that's in my topic branch to join the develop branch and be part of the value stream that goes into environments. And so this is the basic work cycle, right? And so you're going to want to do that over and over again during the day. So one of my pet peeves about pull requests is I love pull requests. I think they're the greatest thing since buttered bread. And depending on your tooling, your pull request may even be able to be a gated check-in, which is to say, once you approve the pull request, what happens is it tries to do a CI build, and only if the CI build passes does the pull request succeed in taking the code out of your feature branch and putting it into develop. But my pet peeve is I've been to a lot of organizations and I've watched people do pull requests. Not the people making the pull request, but the people reviewing the pull requests. And they don't actually read the code. Now, there's two reasons for this. One is our pull request is stupid big. And it's nearly impossible to figure out what's going on. So one of my pleas to people is, even if the feature's not done, if the feature is safe to put into the main code base, the fact that your story isn't done yet shouldn't necessarily block you from doing a pull request, assuming you're not breaking anything. So it's not unusual in well-run shops, especially mine, that for a particular story, you'll see anywhere from 1 to 20 pull requests. And the 20th pull request is the pull request that then satisfies the story as far as we know. And of course, QA and UAT are going to be the final arbiters on that. So if we do a whole bunch of really small pull requests, then the person reading them is much more likely to look at your code and do something useful. And my second problem with the pull request process is that many organizations don't operate off a checklist of things to do, right? If we have a checklist that says, in order for our pull request to be approved, right, I need to do my due diligence as the reviewer and do some things before I approve the pull request. And so here's a straw man of what a good peer review checklist looks like. What I tell organizations is take this basic list, organize it however you want, add sub-steps to it or specifics where it applies. But this is the things we should be looking at. And notice that the number one thing on that list is it meets the business requirements. And then it conforms to the shop standard and whatever. And then we apply our design mind to things, right? We say, is it solid? Is it Yagni? Is it dry? Does it have the required metadata? And then, is the pull request of a reasonably sized scope, right? 10 files is kind of the upper limit of a pull request in my mind. Unless you're doing some humongous China breaking refactoring where it's all or nothing, there's no way to do an incremental refactor, which generally implies that you've made some really horrible design decisions along the way, right? And that your code is so dependent on base classes or conventions that it's brittle, that you should be able to do things in bite-sized chunks of work with one intention in mind. So take this basic checklist, right, and blow it out to meet your organization and its standards. But these are the high level things that as a human reviewing somebody else's code, you should do. We go back to the branching thing, right? Simple branching. Other than feature branches, of which there could be a multitude, you should strive to have as few branches as possible. And we've talked about develop and master or just master-based projects. And we should talk about the fact that each build should get a semantic version tag. And you recall from our little class structure diagram that tags are a 0 to many on a commit being the most important thing. It's the root of the tree. That tags and branches are just pointers to a specific commit. So when we do a build, it would be nice to put that metadata on the commit so that we can, when we do a git history or git log or git blame, we have some information about whence that came. I want to stop and talk a little bit about semantic versioning. I did a whole video on this you can go watch, but teams should absolutely adopt semantic versioning, no arguments, no ifs, ands, or buts. Make the change now and do it in such a way that wherever you left off from branching versioning names, that you start with a major that exceeds that thing. And if you're using alphanumeric versioning, then you should just stop doing that. So follow semantic versioning rules. And why is that relevant? Because we want to put tags, which are pointers with metadata to a commit, right? So we want to associate a semantic version with commit, a repository ID, a work item. So for example, if you're using Jira as your backlog engine and each Jira story has a unique number, we can have a shop standard that says that we're going to add the story IDs as tags to the commit so that we can trace the commit back to the story. And most backlog tools like Jira or VSTS or whatever have a convention. And if you're running the right plugin, what will happen when you do a commit and you include a tag that has the story number in it, it's smart enough to then add metadata to that story that says, by the way, this commit with this comment is part of this story. And so you should, as a team, right, come up with a tagging convention that says, these are the kinds of tags we're going to have. This is what human or entity makes those tags. And we want to make sure that, and this is the default usually if you're using GitHub, Bitbucket, etc., that the tags are pushed to the origin with the commits. So we want to use annotated tags wherever possible. And an annotated tag is a simple git tag is git tag and then the -a part, but without the -a and nothing. And what that says is I want this tag to be on the current head, that it's a pointer to my current commit. In fact, what we usually want to do is do annotated tags. So we want to add a message, an M part to that. In that case, we want to use the long format of git tag -a tag. Notice we're using semantic versioning here. And it's, by the way, completely up to you if you want to include or exclude the V for version. Although typically that's a great way of disambiguating that tag from other tags, tag types, that is. And then you'll notice that my message part has release candidate for features 325 and 424. In your CI/CD process, you can have it do tagging too. And I'll point out that the missing parameter on git tag, we said by default it'll pick the pointer to the current commit. In automated tooling, you probably want to add one more parameter, which is to actually spell out the hash of the commit. That is to say, E41B XXXXX, right? And that makes sure that the tag gets applied to the commit you intended. This also allows you to retroactively tag. Like if you spaced and forgot to add a tag to a commit, if you do a git history and find out what the unique ID of the commit is, you can do an annotated tag and supply that last parameter of the commit hash, and it will cheerfully go through and retroactively add your tag. So here's some sample tag patterns that you could use. And again, these will probably be driven more by the ability of other parts of your DevOps automation to parse this and do something useful with it. So for example, the message CI 3213 refers to build number 3213 in my Jenkins system, right? So if I'm looking at my Git history and I want to know what happened during that build, I can go into my Jenkins, do a search for build 3213 and pull it up. The next part is success. Well, that's a nice thing to know. And then I can, I don't have to go into Jenkins to find that out, right? I can just look. And then repo ID, A5, blah, blah, blah. And what that means is, in my case, it's JFrog Artifactory, but it could be Nexus or whatever. We can go in and take that ID and go into our artifact management system, which is our binary file management system, right? I can take that identifier and I can go do a search on it and actually look at the stuff that's in there, right? In the case of CD builds, right? We can say, you know, we took our repo elements, right? Our war file, our zip file, whatever our unit of deployment is that got written to our artifactory, and we can say, using, you know, workspace configuration 4xp32, we deployed that to the QA environment. And again, our automation will typically spell out the identifiers, right? So at any given time, we can look at our infrastructure and generate a checksum, which includes the checksum of the configuration, and give it a unique checksum. And somewhere in some repository, we can recreate that exact environment by essentially replaying all of the steps that were used to create the environment with that ID. So if you're running Chef or Ansible or Terraform or whatever, you should be able to recreate the exact environment you deployed to using those tools and this piece of metadata. Because our code, whether it runs successfully or not, is often dependent on the configuration of the infrastructure we're deploying it to. And so being able to A, know what that was, and B, recapitulate it is a good thing. So annotations allow your team to link forward and backward through your automated systems. And by that, I mean your DevOps tooling. The one I do constantly is Git status. And I'm a command line guy because I'm old and a Luddite. And so I find myself using the command line tools a lot. And if you use the command line tools and know how they work, then you'll know what the UIs that people have built for them are actually doing. And some of the UIs are really great in that they actually keep a log of the UI composes a Git command, forks a process to execute it, and captures not only the command, but the output, and then obviously brings back the output to the UI. And those are really cool because if you don't know how to do something in Git, you can use them and go through the logs that the tool keeps and see what exciting command it actually executed. And then it's important to know how to undo. And again, if we're in Eclipse or Visual Studio or Code, we can right mouse click on a file and click and pick undo. And then depending on whether it's staged or not, modified or not, whatever, we can go to the root of our source control and we do undo all. What is it doing? It's doing a git reset hard head. And so there's a really great tutorial by the Atlassian people, and these are 3 highlights. These are 3 that I use with some frequency. And again, if you're doing things in a UI, it'll sort of do the right commands for you, but you should probably understand what they are if you want to be successful.